Hi everyone, my name is Amitesh, and in this video we're going to talk about one of the most famous sums in mathematics. And the sum is the following. It's basically what you do when you add up the first so many numbers. So you start off with 1, then you take 1 plus 2, then you take 1 plus 2 plus 3, then you take 1 plus 2 plus 3 plus 4, then you keep going. So you take 1 plus 2 plus 3 plus 4 and you add up all the numbers all the way up to anything you like. So for example, you can add up all the numbers up to 10, for example. And you can say this. So this dot 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 means that you're saying 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay? And you can keep going. Then you can talk about 1 plus 2 plus 3 plus 4 plus dot 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 all the way up to 100. So this means you're adding 100 numbers together. 1 plus 2 plus 3 plus 4 plus 5 plus 6, etc. up to 99 plus 100. And in this video we're going to talk about a really beautiful trick for actually finding these sums. And it wouldn't matter what the final number is, whether it's 100, 1,000, 856,212. This trick is going to work and immediately tell you what the sum is going to be, what the answer is going to be. And I'm going to do a few videos on this. In this video I'm going to talk about the classical method, and there is a story behind this which is about a very famous mathematician, one of the most famous mathematicians. His name was Gauss. He is said to have discovered when he was very young, maybe around 7 or 8 years old, his teacher in his class gave all the students this question of finding 1 plus 2 plus 3 plus 4 all the way up to 100. And as you can imagine, this is a very difficult question when you see it for the first time, because the natural way of trying to do this is just to keep adding the numbers together. You add 1 and 2 and 3 and 4, etc. But as you keep going like that, it's going to take a really long time to get up to 100. And so the teacher expected, people can do this, but it would take a while. But Gauss apparently answered the question immediately. And this was a big surprise to his teacher. And he found this beautiful method for finding this sum, which is what we're going to talk about in this video. And in future videos, we're going to talk about other methods for finding this sum, as well as a formal mathematical proof using induction for finding this sum. And the induction proof, even if you don't know anything about mathematical proofs, that video will be super accessible, and links will all be down in the description. Okay, so this video is just an introduction. Let's dive right into it. So we want to figure out how to understand this sum. And I'm going to talk about a thought process. Okay, so we're going to just kind of play around with this, because math is really like a game. You're playing around. It's like you're lost in the forest and you're trying to find your way out. You're trying to find some beautiful trick, and that's what we're going to look at. So here we start off by first thing we can try to do is just add the numbers together. Okay, so we can sort of say 1 plus 2 is equal to 3, 1 plus 2 plus 3 is equal to 6. Every time I'm adding the next number, okay, to the answer. So 1 plus 2 plus 3 plus 4 is going to be 6 plus 4, which is 10. So you get 10. Then 1 plus 2 plus 3 plus 4 plus 5 is going to be 10 plus 5, which is 15. And you can keep going with this. 1 plus 2 plus dot 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 all the way up to 6. So I'm just adding all the numbers 1 to 6. That's just going to be 15 plus 6, which is 21. And I can keep going, and there doesn't seem to be any pattern here. I mean, you just have to keep adding the numbers together, and once you start adding numbers like 60s and 70s, it's going to be pretty challenging if you want to add up 1 plus 2 plus 3 up to 100. Maybe not mentally so challenging, but very time consuming. And suddenly if you have a number like adding up 1 up to 1,000,000, you cannot do this method. I mean, it's just not going to be humanly possible to be able to add that many numbers together. So what we're going to do is talk about this beautiful trick that Gauss is said to have discovered, and this is a legend, so it's not 100% verified, but it's definitely plausible that a very young child or anyone can actually discover this with creativity. So let's talk about what this trick is. So I'm going to sort of motivate it by taking the first kind of large sum, which is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Okay, so 1 plus 2 plus, I'm just going to write it all out. So 7 plus 8 plus 9 plus 10. And what we're going to do is, instead of just adding this blindly, we're going to do some really funny thing that looks like it's not really deep, but actually is pretty deep. And this is what Gauss discovered. So, or said to have discovered. So the idea is that adding numbers, it doesn't matter in what order you add the numbers together. Okay, so you can add them from front to back, you can add them from back to front, you can add them in any order you like. You can add, you know, some numbers here and some numbers here, and then kind of take care of it that way. And what is really cool is, if you add them in a clever way, some beautiful thing emerges about what the answer should be. So I'm just going to show this to you, and I encourage you to think about this problem yourself as well. You know, like, just play around with it. You know, pause the video, play around with it, think about how you'd find this sum, use smaller sums if necessary, try to think what the trick could be, and you know, pause the video and then kind of hear what it's going to be. So what we're going to do is, we're going to do the following. We're going to add, instead of adding them in the forward way, we're going to essentially, I'm just going to get this marker, we're going to add them in the following way. We're first going to add 1 and 10 together, the first and the last numbers, okay? Then we're going to add 2 and 9 together. These are the second and the second to last numbers. Then we're going to add 3 and 8 together. And I want you to think, as we're going along, what's actually happening, you know, if you haven't seen this before. Then we're going to add 4 and 7 together. And finally, we're going to add 5 and 6 together. All right. So that's what we've done. We've added these numbers together in this way. And why have I done this? So I'm going to ask the following question. What is the sum in each case? What is 1 and 10 adding up to? So let's use a green marker. What is 1 and 10 adding up to? 1 and 10 is adding up to 11, right? Similarly, 2 and 9 is adding up to 11, 3 and 8 is adding up to 11, 4 and 7 is adding up to 11, and 5 and 6 is adding up to 11. So now the question is just to add 11 to itself 5 times, which is a lot more structured than adding a bunch of different numbers. It's just the same number adding to itself a certain number of times. And what does it mean, right? What does it mean if I'm saying I want to add 11 plus 11 plus 11 plus 11 plus 11, that's 5 11s. That sum is just going to be equal to 5 times 11, which is equal to 55. So that's going to be the answer to 1 plus 2 plus 3 up to 10. And already this method is a lot more beautiful than just adding them up from forward to back, because you kind of see some pattern here that might enable you to find even bigger sums. And I want you to actually try this method as a sample. Try it and see what happens when you do it up to 100. Or if you like, play around with up to 20. But try to kind of see the pattern. And now we're going to talk about that. So let me erase this. All right. So the next sum I'm going to do is, I'm going to do 1 plus 2 plus 3 up to 50. Okay, so let's go up to 50 first and see what happens. 1 plus 2 plus 3 all the way up to a 50. Now, if we try the same method and we pair things up, so let me actually write this out a little differently just so you can see the first so many pairs. Okay, so let me add, you know, 1 plus 2 plus 3 plus 4 all the way up to plus 47 plus 48 plus 49 plus 50. Okay, so we're adding these numbers up. Let's now pair them. Okay, so the first number and 50, 1 and 50, if we pair them up, then we can pair up 2 and 49. Then we can pair up 3 and 48. Then we can pair up 4 and 47, and so on. Now I hope it's evident, or if you look at it for a little bit, it's something you can observe, that 1 and 50 is 51, 2 and 49 is 51, 3 and 48 is 51, 4 and 47 is also 51. And if you keep going, you will keep getting 51s. Because every time, you know, 1 and 50, then you're adding 1 to get 2, and then you're subtracting 1 from 50 to get 49. And then you're and then when you do that, your sum is not going to change because one of the numbers is increasing by 1, the other is decreasing by 1. So the sum is not going to change, same as you go at 2 plus 49 to 3 plus 48 and so on. So the real question here is how many 51s do we have, right? How many 51s do we have? So the way I like to think about this, just to kind of, you'd expect roughly how many it should be. You expect that it should roughly be around half, right? I mean, that's what you expect it to be because you're pairing up the numbers, right? So you've got 1 and 50, 2 and 49. So there are 50 numbers in total and each pair is going to be 2. So it's going to be 50 over 2 different pairs, which is 25 pairs, right? And it's going to go all the way up to, if you add them up, it's going to be 25 plus 26, okay? So here it was 5 plus 6 between 1 up to 10. And the last pair is going to be 25 plus 26, which you can also check is equal to 51. So you're going to have 25 such pairs. So they're going to be 25 51s. And the answer is going to be 25 times 51, right? That's what the answer is going to be. And for this, you can just, you can just multiply them out together. And one way I like to multiply this kind of thing is 25 is 1/4 of 100. So it's a mental trick. So you can say it's like 5,100 divided by 4. And then you can sort of figure out what it should be. It's going to be 1,275. Okay, so that's going to be 25 times 51, and that's going to be the answer. All right, so we've got that. That's the sum 1 plus 2 up to 50. How cool is this? I mean, if you think about it, this is a very complicated sum. Adding that up by hand would have taken a long time, but somehow with this trick of pairing the numbers up, it turned out to be a lot more manageable. And we can keep going. We can add them up all the way up to 100. And I want you to actually do that and then pause the video, add up to 100 and see what you're going to get. Okay, so let's do that next. And this is the sum that Gauss is said to have discovered, is 1 plus 2 plus 3, etc. up to 100. And we can actually kind of bypass a lot of the process. We don't have to kind of think through all the steps here once you've got the hang of it. So if you have 1 plus 2 plus 3 plus 4, etc. up to 96 plus 97, or 97 I guess, 97 plus 98 plus 99 plus 100. The reason I said 97 is I want to show the first 4 pairs. So you can again like pair things up. So you can, what you can do is you can pair 1 and 100. So what are you going to get when you pair 1 and 100? You're going to get 101. And you know that the other pairs are also going to add up to 101. It's the same pattern as earlier. So then you pair 2 and 99. You're also going to get 101. And then the question is, how many pairs are there going to be? Where is it going to go up to? So as I said, cool trick is, there are 100 numbers you're adding up. If you pair them up, they're going to be 100 over 2, which is 50 pairs. Okay, so this is going to equal to 101. They're going to be 50 101s. And if you like, it's going to be up to 50 plus 51. But you don't even have to know this, what the last thing is. You just know there are 50 pairs. That's all that you need. And that's going to be 101 times 50. So again, you just multiply. I mean, this is a bit easier because you have 101 times 5 is 505. And then you add a 0. So you get 5050. So again, very, very cool and quick to find out the sum 1 plus 2 plus 3 up to 100. Okay, so this is how we find this sum. And you might ask, okay, we can do this, right? We can do this trick. Now, there's one kind of subtle point, and I'm going to show this to you with the number 5. So if we try to pair up 1 plus 2 plus 3 up to 5, for example. So let me erase this. So if you try to pair up 1 plus 2 plus 3 up to 5, you will run into an issue. Okay, so let me do this. Let me just split the board in half. So 1 plus 2 plus 3 plus 4 plus 5. What happens if you do the pairing process? Just kind of think about this. Again, like you can pause and sort of see what happens. But 1 and 5 get paired up. 2 and 4 get paired up, and 3 is not paired up. Okay, so 3 is kind of unpaired, but you still have, except for 3, except for this middle number, you can sort of add up 1 and 5 and get 6. 2 and 4 will also be 6. So you can say the answer is 6 times 2 plus 3, which is 12 plus 3, which is equal to 15. And if you had something a bit more difficult, a bit bigger, you would still have the same problem. The issue is that 5 is an odd number. So all the final numbers we've considered so far, 1 plus 2 plus 3 up to 10, up to 50, up to 100, they were even. So when you paired them up, you divided by 2, you got another whole number, and you could do the multiplication. Unfortunately, for 1 plus 2 plus 3 up to 5, 5 is odd, so one number in the middle does not get paired. So how are you going to handle this? So, I mean, even if I had something, so let me sort of look at an example. Let's look at a large example, okay? So get really large. Let's look at 1 plus 2 plus 3 up to 9, okay? So 1 plus 2 plus 3 up to 9. Plus 5. I'm just going to write it out very explicitly so that, I mean, I was going to do 99, but yeah, I mean, let's do actually up to 99. Try to guess what it should be. So let's kind of keep it large. So 3 plus 4 plus all the way up to 99. So since 99 is odd, one number is going to get left out. And this is a good mental exercise. What is the number that gets left out? What do you think? Like, you can drop it in the comments below or just mentally think about it. I love it if you drop it in the comments. What the number is not paired is, and then we can sort of see. So let's kind of see what this is going to be. So again, you can sort of pair things up as you for the beginning. So I'm going to indicate what the last numbers before 99 are, so you can kind of see how the pairs work. So we're going to have the last 4 numbers are going to be plus 96. So dot 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 is all the numbers in between, plus 97, plus 98, plus 99. And what you can do is you can kind of pair up. You can say 1 gets paired with 99, 2 gets paired with 98, 3 gets paired with 97, 4 gets paired with 96. So you have 1 plus 99, then you have 2 and 98, then you have 3 and 97, and then you have 4 and 96. And by the way, one thing I'm trying to do is to go through the thought process. Like, it's very easy in math, people do this, is just give kind of like the neat final answer to everything and just say this is what it is. But actually, like, math is not discovered in that way. Eventually, people have to synthesize it and communicate it in a clean way. That's a process. But the thought process is important, and it is a messy thought process. It's not as clean as it's presented in textbooks or in lectures. So here we're kind of seeing that, okay, we had a problem with our method. Now we look at the case of odd numbers, and we sort of understand how it works here. So what number do you think doesn't get paired? So the way I like to think about this is, every time, so 1 is paired with 99, and then if you add 3 to 1, you get 4. And if you subtract 3 from 99, you get 96. Okay, so you sort of think, what do you add to 1 and then subtract from 99 so that one number is less than the other, right? So if I consider a number like, you'd expect it's roughly around half where things don't get paired. So you can kind of experiment. Suppose I say 49, right? 49 is 48 more than 1, and 48 less than 99 is going to be basically 51. So 49 and 51 is going to be the last pair, because then 50 is just going to be unpaired, right? So that's kind of the thought process there. And that, you don't have too much of a difficulty here either, because what you can do is you can just say that, okay, 1 and 99 is 100, 2 and 98 is 100, 3 and 97 is 100, 4 and 96 is 100, 49 and 51 is 100. So how many hundreds do I have? And then you just have to add on the 50. So it's kind of the same idea. It's just a minor tweak, and it looks a little not so nice, but it can still be handled. So here you're going to have 49 hundreds, 49 times 100 plus 50, which is going to equal to 4900 plus 50. So add 2 zeros to 49, add 50, it's going to be 4950. So that's going to be the answer. Okay, so suppose I'm just going to end this video by talking about what's the general formula going to be, right? I mean, we can sort of do all these examples. So presumably now, if you think about it, if I give you any sum, you can work out what it is. And I actually encourage you to try some numbers. Try 1 plus 2 plus 3 up to 78. Ask your friends, like if you think they haven't seen this before, your family, your friends, ask them how they would do this. It's kind of a fun exercise, then you can sort of show them how it works. But what would be really cool in math is if we had a general formula, a general thing you can just plug in. Here's the formula, here's the answer, right? And that's really, really cool if we have such a formula, and we do have such a formula. And I'm going to say what the formula is, but I'm first going to explain it piece by piece. We're just going to think about what it should be, and we're going to think about the even numbers first, like 1 plus 2 plus 3 up to 100, those kinds of numbers, and then we're going to handle the odd numbers, okay? And for handling the odd numbers, I want to give you one cool observation. How would you find 1 plus 2 plus 3 up to 99 given what we already know in the video beforehand? Suppose we didn't go through this process, but we've already found a sum in the video which is very close to this one. Okay, what was that sum? What was that sum? So the sum was 1 plus 2 plus 3 up to 100. We found that 1 plus 2 plus 3 up to 100 was equal to 5050. How would we go from the 5050? Suppose I didn't do all this process. How would I go from the 5050 to the 1 plus 2 plus 3 up to 99, which is the 4950? Well, the only difference between this sum and this sum, what is the thing you think? You can just think about it. It's just going to be subtracting 100, right? Whatever this is, subtract 100 from it, and you're going to get this sum, because you're just not adding the 100 for this sum. So you can see that 4950 is going to equal to 5050 minus 100. And that would be a quick trick to get the sum for an odd number, is just add up the even number that comes after it, use the method that is nice where you just pair things up, and then subtract off that number. Okay, so that's one method of doing it. There are many methods of doing this. I'm trying to sort of motivate how you can think about it. If you have any other interesting methods of doing it, leave it down in the comments below. I'd love to hear it, because there are quite a few methods for solving this, and you might just discover your own method. So think about it, drop it down in the comments, and it would be great to have a discussion. But let me just tell you what the formula is. So I'm just gonna, and this is kind of really sort of a very cool formula. So the formula is the following. And it involves the use of variables, okay? So I'm going to sort of explain this. If you haven't seen that before, don't worry. If you have, that's great. So suppose we want to find 1 plus 2 plus 3 up to something, and the something we don't know, but we want to be able to give a method that just says that if I tell you what the something is, you can just tell me the sum, right? The only thing I need to know is what we're adding up to, because if we add up to 10, the answer is different from we add up to 100, or if we add up to 1,000. So this is why this we call a variable. It's something that could be anything. Could be adding 1 plus 2 plus 3 up to 10, up to 100. So variable means something that changes. So typically in math, we denote variables by letters. So instead of a question mark, something we don't know, we also call it n, which is also something we don't know. Okay, so 1 plus 2 plus 3 up to n. So for example, just to illustrate, this is nothing fancy. If n is equal to 10, right? If I say n is 10, then this is just going to be 1 plus 2 plus 3 all the way up to 10. If n is equal to 100, then this is going to be 1 plus 2 plus 3 all the way up to 100, right? So there is nothing, it's just like n is just indicating that it could be anything we're adding up to, but when I specialize, when I say what n is, you get a specific sum. So our formula should basically take our n and say what the sum is just in terms of n. So we can then plug into that formula rather than finding the sum from scratch. And let's see what that should be. So that should be the following. So let's kind of talk about the case where n is an even number. Okay, so where n is an even number. So in this case, what's going to happen, right? So what's going to happen is we're adding up 1 plus 2 plus 3 plus dot 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 plus, and this is something I'm going to just like explain, n minus 2 plus n minus 1 plus n. So what does this all mean? Well, n minus 2 is something which is 2 less than n. You know, so if n is 10, n minus 2 is 8. You know, if n is 10, n minus 1 is 9. And if n is 10, then n is 10. So it would be like 1 plus 2 plus 3 plus 8 plus 9 plus 10 if n were 10. But by writing n minus 2, we're saying that no matter what n is, the third last term is going to be 2 less than it. Okay? So 1 plus 2 plus 3 up to 10, the third last term is 8. The second last term is 9, which is always going to be 1 less than the last term. So by writing in this way, we've explained what all the terms are in terms of n. And this is important because when we try to explain what the sum should be, we can again pair things up. So I'm going to pair things up in the following way. So I'm just going to erase this. I'm going to pair up 1 and I'm going to pair up n. I'm going to pair up 2 and I'm going to pair up n minus 1, 3 and n minus 2. So what happens when we do these pairs? So let's talk about it on this slide, or not slide, but like second half of the whiteboard. Okay, so let's talk about that. So on the second half of the whiteboard, we're going to basically say that this is going to be 1 and n, right? That's going to get paired up. Okay, so 1 and n. Then we're going to pair up 2 and n minus 1. Okay, so 2 and n minus 1. Or another way, maybe I'll just do it. It's the same, it doesn't matter what order we do this in, so I'm just going to do it in this order just so it's a little bit more visual. We pair up n and 1, n minus 1 and 2. Then we pair up n minus 2 and 3. Remember, the principles are all the same. Just because I've introduced an n, it's the same principle that if you add up the first and last terms, you just get n plus 1. I mean, just something equal to itself. But when you add up n minus 1 and 2, you also get n plus 1. Basically, 2 more than 1 less than n is 1 more than n. If you subtract 1 from a number and then add 2 to that result, you're just adding 1 to the number. So here you're just going to get n plus 1. Here you're also going to get n plus 1 because you're subtracting 2 from the number n and adding 3 to the number, so that's 1 more than the number. So you can keep going, you're going to get all these n plus 1s, and the point is that it's the same idea as usual, you're just getting the same sum. How many times is that appearing? How many n plus 1s do you have? You know, so what do you think? You know, how many n plus 1s do you have? Do you want to drop a comment down below? What do you think before we kind of say what it should be? And think about, like, you know, 1 plus 2 plus 3 up to 10. You know, always try to think what it was in the examples to kind of get what it should be in general. So 1 plus 2 plus 3 up to 10, you know, you are basically having 11s, if you remember earlier in the video, and you had 5 11s because 5 was 1/2 of 10. So there should be half the number of pairs. You know, if you take a number, you add 1 up to that, 1 plus 2 plus 3 up to that number, they're going to be that number divided by 2 pairs, right? So 1 plus 2 plus 3 up to 100, they're going to be 50 pairs. So it was 101 times 50. Similarly, here they're going to be 1/2 of, so I'm just going to say n over 2 n plus 1s. Okay, so n over 2 n plus 1s. Maybe I will say n over 2 n plus 1s. And the sum of n over 2 n plus 1s is actually just going to be the product, right? If you add a number to itself so many times, it's going to be n plus 1 times n over 2. And n over 2 is just 1/2 of n. So if n is 10, this would be 5. If n is 100, this would be 50. So this is kind of how we can write the formula. It's just n over 2 times n plus 1. And if you like, when you multiply fractions, you know, you can just write this as n times n plus 1 over 2. And that's going to be the answer for 1 plus 2 plus 3 all the way up to n. That's going to be the formula. Okay, and this is a really cool formula because we can actually plug things in. I just want to show you, if you plug things in, what happens. So if you want to find out any n, it's a silver bullet. It's a magic pill, if you like, to just answer any such problem. So if you're adding 1 plus 2 plus 3, if I ask you what is this up to 10, you know, you just have to say what is n? What are we adding up to? We're adding up to 10, so that means we have to say 10 times n plus 1 by 2. So 10 times 10 plus 1 by 2, okay? So 10 times 10 plus 1 by 2, and brackets, you always do the brackets first. There's nothing in this, it's just, remember, it's 1/2 n's of n plus 1s. So it's 10 times 10 plus 1 by 2, which is 10 times 11 by 2, which is 110 over 2, which is 55. Okay? Similarly, if I do 1 plus 2 plus 3 up to 100, it's just going to equal to, what is n here, right? N is going to be 100. How many of them? So n is going to be 100. What is n plus 1 going to be? 1 more than 100, which is 101. So we're just multiplying 100 times 101 divided by 2. So you add on 2 zeros to the 101 divided by 2. And if you look at this, this is just going to be 10,100 by 2 is 5,050. So we've magically got the sums that we've already done because this is the general process that we derived from those examples. And we can do any example, right? So we can do, for example, suppose you wanted to do your favorite sum, you wanted to do, 1 plus 2 plus 3 up to 60. Or let's do up to 20. Let's just take a small number, right? It doesn't matter. 1 plus 2 plus 3 up to 20, as long as the end is even, because that's how we derived it in that case, we can just say that it's going to be, here n is 20, we're just going to get n times n plus 1, 1 more than 20 is 21. So we get 20 times 21 over 2, which is just going to equal to, 20 times 21 over 2 is 10 times 21, which is just going to equal to 210. Pretty cool. We just found out the sum. At the beginning of the video, this would be mind-boggling if you think about it, if you've never seen this before, that we can just plug in the formula and get it. And actually the formula is the same even when n is odd. It turns out to be the same answer. I won't actually explain this in this video. I'll leave you to think about why that should be or whether you can find a way of understanding that. Think about that. Leave it down in the comments below if you have a method or if you have an idea of how you do that. But this is the general formula for 1 plus 2 plus 3 up to n. And I hope that this process kind of was enlightening, as when you see this kind of problem, how we found this creative trick. This is what math is all about. It's about finding these creative tricks for answering problems that look really hard. Just getting to the heart of why they're true. And I'm going to do a few other videos, probably 2 other videos on this, where I talk about another method for finding this sum, which I also really like. It's something that I actually came up with, but I'm sure that it's probably known, but I did come up with it once and I like the way it works as well. And in another video, I'm going to talk about a mathematical proof. So if you haven't seen this, mathematical proofs are about just very rigorously kind of giving an argument without doubt that something is true. And there is a proof method called induction, where basically it's a very common proof method where you just kind of reason that something is true for infinitely many things, So no matter what n is 100, 1 million, 5 billion, this formula is true. So there is just this rigorous argument that explains why that is true that I will do another video on. So thank you so much for listening. I hope you loved this video and I really enjoyed making it. It was a lot of fun to do this. And this is one of the things I've seen in math when I was young, and I really loved it and found it really beautiful. I hope you had the same feelings, if you haven't seen this before. Or even if you have seen this before, I hope you enjoyed the exposition, which is just going through the thought process of how you think about these problems. So it would mean a lot to me, if you enjoyed this video, if you could leave a like and subscribe. I would love that. It would help disseminate my videos to as many people as possible. And my goal is to create free and accessible math education worldwide, so that everyone can really enjoy and love math as much as I do and really be inspired by it. And by liking and subscribing, which is free, just like YouTube is free, watching the video is free, Liking and subscribing is free. It takes a second, just go ahead and click that button. It would mean a lot to me. Thank you so much. I hope you have a wonderful day wherever you are. I wish you all the best. And I'm super excited, leave a comment, if you have any feedback, thoughts, comments, I'd love to hear it. I wish you all the best. And I'm super excited to see you in the other videos. I've left in the link down in the description my other videos on this topic. So please check that out if you're interested. Hope you have a great day, evening, or night, wherever you are. And I will see you soon.